All right, session 6, we are meshing. So I'm going to go to the mesh tool, or mesh ribbon. Realize I've been in an OptiStruct profile. That's just a structural solver we have. Let me go and change our solver interface back to FEKO. None of the tools really are going to change up on what we did, but if you were seeing some different tools on there, my apologies about that. Okie dokie. So here's our plane that we've been working on. It's nicely, we've done quite a lot of damage to it, but such is life. We're going to go ahead and mesh. I'm going to show you some of the mesh options that we have and the ones that I would recommend if I were a FEKO user. Yeah. So the first one is just a general 2D mesh, right? So as we've clearly established, usually you're just going to be working with the surfaces, the solid, entity itself. We don't need to focus on all that much. So we're just going to work on these surfaces, and under the 2D mesh, we will have the ability to just do this. So once again, I'm just going to select, keeping in mind your unit system. Once again, HyperWorks is unitless, and I've been jumping around models. I don't actually know how big things are anymore. So I'm just going to go to the measure tool, and I can measure. It kind of shows me radiuses. Doesn't really do a whole lot for me. I need a length. So the wing is 12,823. I'm going to assume that's like millimeters, or no, centimeters, maybe millimeters, 12 meters. That's a decent size. All right, we'll assume that's meters-ish. Okay, so probably a mesh size of, I sometimes like to use this little thing at the bottom. It gives you an idea. Maybe a mesh size of like 200 should be a pretty decent mesh size. Just kind of line that up and see what 200 is going to look like. It's going to be decently coarse, but it's going to be fine enough. So back to my general 2D meshing. Anytime I say general 2D meshing, I think of How I Met Your Mother. They do general meshing. Got a salute. So 200 in here. I'm just going to leave all the defaults. So we're going to talk about some advanced options in here as well. But so we're going to do a lot of meshing and then say, no, don't do that. Let's undo. So here is our general 2D mesh. Okay, so HyperWorks started out as a structural solver. It's usually going to default to quad elements, right? It just wants to see quads because quads are good. A minimum amount of trias, but we'll put in a triangular element when we need to. Okay. So understanding for FEKO that this, everything is more of an STL mesh. Even if you're not using this for FEKO and you're using this for a different electromagnetics tool, most things are STL as far as I have understood. So this is not the greatest mesh in the world for you, but just kind of looking at it, it's not bad, right? These circles look pretty good. The flow is pretty nice. There's certainly triangles that we can get rid of, and you can make an argument for why are they there, etc., etc. But these are the default options. Okay, the default options also give you this kind of weird view where everything has a number on it, and you might be a little wondering why everything has a number on it. And everything has a number on it because these are the node seedings on each of the lines that are within the model. Okay? Which means, which also allows us the ability to come, say, like to this tail section where the leading edge has 36 nodes on its line, and the trailing edge has 34 nodes. And if you were a betting man or woman, you would probably say, well, I want those to be the same. And within this, we call this interactive mode. You can actually select this edge and tell it, I actually want 36 elements in there, right? So let me move this out of the way. 36 nodes seated on that edge. Again, not necessary to do, but this is the kind of level of control that you have over the mesh within HyperWorks, right? So that's really what we're going to show here. So I can click on edges to change seating up, down. There's options for biasing or element size, right? So I can check the element size here. So instead of 200 now, you see it when I added 2 more nodes, it bumped it down to 190, but I'm more of a density guy, to be honest. That looks fine. Just hit escape. come back here. Maybe I wanted some more nodes on this back tail. Maybe I wanted 40. This is the kind of granularity that you can get into. For some of you, this is way too much info. Completely understand that. There's also biasing up here. So under this general 2D mesh, after we've gone and created it, you see that we're in this density option. Okay. We can also go to biasing. So I can come in and say select an edge and bias to a certain side. So you see this is kind of all starting to stack towards the fuselage area, so away from the wing tip. Zoom in here a little bit more to the fuselage area. Okay, and then the mesh updates accordingly. So this could be something where you could bias to a certain area. You could have a much higher bias in areas, so there's more nodes packed in. Certainly something you can do, right? The biasing is in here. The second thing that you'll notice is that we changed the coloring, right? So the coloring is based over here on this legend to the right. Some things are applicable, some things are not applicable. But if you're really kind of curious, you can come to each one of these individual options and kind of get a nice little contour plot, as well as ISO plot of some of your mesh quality statistics, right? So things like min size, right? So you kind of see most of them fall within this kind of 300 to 200 range, right? That's where I kind of specified my element size to be. But if you were worried about where are my smallest elements, well, obviously where I went and biased a whole lot over here, right? The elements got packed in a little tighter, so they're much smaller. Or they're smaller to capture certain features. Okay. That's something that you have here. You can also do with this max size. Once again, a nice little slider. Get some cool pictures, aspect ratio. As far as mesh goes, I'm not 100% certain what the most important thing is for, say, a FEKO mesh, but Jacobian is always kind of a good overall measure of quality, right? So if you are just kind of wondering about the quality of the mesh, okay, that's in there. Maybe taper or skew; those could be important, I suppose. I don't know how many of these. Yeah, the skew's pretty low on these, so. Just different options in here, right? So that's something that we can do. So this is just the general meshing, right? Like I said, this is not a good FEKO mesh. So what I'm going to do is I'm going to escape out of the tool. I'm going to change my selector to elements. I'm going to go Control A to grab all of them, and I'm just going to blow them away. Hit delete when I'm gone. All right, let's go back to general 2D meshing. Like I said, we're going to mesh this part a bunch of times because I want you to see some of the differences here. Once again, I'm going to select all the surfaces. I get my little dialog, but before I actually go and mesh this, I want to look at some of the options that I have in this little hamburger menu to the side. So once again, I have the ability to set a element size. I have also the option to set a mesh type, right? I also have the option to set an element type. Okay, so mesh type is kind of an umbrella. You have things on here like free, mapped, optimized quality, advanced, auto decide is what the default is. And I'm going to leave it on auto decide, but maybe I only want triangles in my model this time, right? Remember last time it did quads and trias as needed, but maybe I only want triangles. So I'll just say trias. The element order, first or second order. Don't know if that's important for electromagnetics. I've always used first order for electromagnetic stuff, but you can change if you want a mid-side node, you can put a mid-side node in. And we'll keep all these defaults. By default, we want the mesh always to be connected. It's going to go to interactive mode, right? So it's going to take us there as well. And then there's options for how this gets organized, which is why we spent a little bit of time earlier in the series organizing my model into left wing, right wing, nose, tail. Again, the more organization that you have, this just allows you for a little more, adaptability. Okay, so I'm just going to say the only thing that's going to change between this mesh and my previous mesh is triangles. So I'm going to go ahead and mesh. And now you'll see there are no quads in my models, there are only triangles. Same thing applies here as far as edge density, biasing, those type of things. You can go in interactive mode, you can come and see min size, max size. The slider is here, sometimes the slider. Give me the slider. Right, min size, max size, all sorts of options here. Okay. So triangles are fine. I think this would be a perfectly decent mesh for FEKO. You see, it's not bad in areas that it needs to be structured. It's completely structured, which is quite nice. It captures most of the features pretty well. Okay, not a big problem here. But we can do better, and we should do better. Elements, once again, I'm going to grab all the elements and delete them. Okay, back to general 2D mesh. Bet you're going to be like, oh, what he's going to do now? I was okay. That mesh was perfectly fine, but it can get better. So the next thing I'm going to change is I'm going to change this adaptive mesh. And what I want to do is I want to do curvature-based refinement, and this is something that I think could be super useful to capturing some more of the complexities that we might be seeing in some of the pieces that we're manufacturing, especially in aerospace, where you have, leading edges, trailing edges, those things that kind of go to sharp points, missiles, fins, those type of things. So I'm going to do curvature-based refinement, and that means that when HyperWorks encounters a place where it would behoove us to have more elements in order to more accurately capture an option, either edge deviation or surface deviation. In this case, I'm going to do surface deviation. I'm going to say, well, I'm going to allow you to go down, to get smaller in element size, right? To pack more elements in such that you can better approximate the surface curvature with more elements. Okay, so that's what these options are in here. Min size factor, max size factor. This is the minimum element size as a factor of an average element size. So 10%. I believe this means we're going to be able to go down all the way to an average element size of 20 in areas that it needs to. But keep in mind that in areas that it doesn't need to, we're going to be able to grow it, right? So that's the maximum deviation factor too. I think that's what this means. It could also just be a bound between 220 and 180, plus or minus 10%, or it's plus or minus 90%. I'm not sure. But guess what? We're going to try and see what happens. Okay, so the only thing that I changed here was that surface curvature-based refinement method. So it is going to take a little longer. Obviously, our mesh count is going to go up. Our node count is going to go up. So all things to keep in mind. But this is going to be a great way in order to capture some of the more fine features of this part. And this part doesn't even have that fine of features, but you're going to see what I mean. Okay, so we can kind of see towards the leading edge now. It's a great place to look. You just see the amount of elements that kind of get packed in here because we have to more accurately capture this feature in order to not deviate from the surface. And if you keep zooming in, you'll see what I mean by deviate from the surface. The graphics kind of start to show that surface poking out. Oh, it's not super evident here. I mean, it's evident, but okay. So here's some options, some places, right? That is the surface kind of poking out, right? And then we're trying to approximate that with a 2D flat planar element. Okay, so if we stack more in here, we'll get more approximate more accurate answers. But I've also heard that FEKO likes a kind of a standard element size. So this is where I would kind of revert to the electromagnetics experts in the field. Once again, this is just a button that we can press in order to kind of stack more elements where features are needed. Okay. All without having to do it manually, I suppose, right? Because I could, you could go and mesh this surface by surface. Whew, that would be a job. Okay, so this was the curvature-based refinement. This is going to be where I'm going to stop deleting the mesh and kind of accept my life. That I think that this is pretty good, right? So yeah, here's a good place, right? So you can kind of see the surface popping through. It would be much, much worse if we didn't have the curvature-based refinement in here. If we wanted to, we could even go in and kind of stack more elements in there. Okay. So this is the 2D meshing that I kind of wanted to show. I think that this is probably going to be a good place to stop for this session. I don't want it to get too long. But again, curvature-based refinement, mesh size, change it to trias. There is an option in here for right triangles. I don't know if that means anything to anybody, but you could do right triangles. And if you did want quads, you can do quads. But I think you usually want to do a tria mesh, because we'll probably spit out an STL file at the end of the day. Okay. The last thing that we're going to do with meshing in the next section is what if there was no geometry. Well, we'll start with geometry, and then what if there's no geometry? So stay tuned.